Hey folks, how's it going? Rob here coming to you with a breakdown of Math 130 problem set number 5. So in this video, I'll be going through each of the problems. I'll be getting at the main ideas behind it, though I'm not going to be going into super big detail. If you do have any questions after this, I do encourage you to reach out to me via email or try to make use of drop-in office hours or regular office hours, depending on how this week plays out. All right? So to jump into things, right, this problem set focused heavily on continuing our look at logarithms. So in the previous class before this, we looked at some of the laws of logarithms, and then we started to take that and say, what can we do with these logs? So we talked about expanding and condensing, and that's where we kind of get started with here. So this homework set in general covered, to my knowledge, expanding, condensing, exponential equations, logarithmic equations, and applications. And so in expansion, all you're doing is you're using the laws of logs. That is, the log of a product is the sum, as you see here. The log of a quotient is the difference. And then also the log of a power. When you have a power, you need to bring that power down and put it in front whenever possible. That's expanding. You make it as kind of blown out as possible, and that's basically what you see me doing here. The other strategy you want to be aware of is you do want to convert any roots. You do want to think about converting them into a rational exponent. And that's more or less what I did there. Condensing basically is going the other way. So you start with something really drawn out, and then you're going to reverse engineer each of the log rules one at a time to go back the other way. You don't want to draw things too far out. And other things you want to note is that, remember, logs can only be combined if their bases are the same. So logs should not combine, for example, in A, because a log base 3 and a log base 10, those do not combine. So those are some things that we look for there. And again, you're trying to make it as condensed as possible. Right? And you're more or less going to see that's what I did there. This one was a little trickier, but again, you're going to first pull it together using the product rule in reverse. You're going to move that exponent up there. You're going to use the, as you do here, and then you're going to use the quotient rule. All right, you would not distribute in, and technically, if we're being technical here, it really needs to be the whole thing that's getting fourthed. Because when you move it up, you're not just doing the fourth on the x plus 5, z plus 5 rather, you're doing it on the z as well. So that technically, you do need to be technically accurate about that. All right, exciting exponentials. This was pretty hopefully straightforward. The idea is you do want to get the base alone. If the right-hand side can be written as an equal power, you can use that one-to-one property, right? That's what you ideally want to try to do. It's the lower energy strategy. It gives that direct canceling, so it is a strategy that you can go ahead and feel free to utilize. And then the other strategy you could do, if you already have the bases equal, you could just directly cancel the bases. And one thing that's cool about that is it works with E as well. You're going to see right here what I did is I used the method of completing the square, though the quadratic formula would also have worked. Here, what I do is you can see I actually applied the laws of logs. So I had the fact that ln of 87 over 4 was the ln of 87 minus the ln of 4. By the way, to the best of my knowledge, I believe that I did check these by plugging back in. These will not have any extraneous solutions, just remember, because you can plug whatever you want into an exponential. All right, any real number at least, that is. So similar idea, you subtract, you divide, and so on and so on. Okay, it's the same. It's basically the same idea with all of them. One thing I did do just to get a little bit fancy to type it in, just remember when you're typing it into your calculator is not going to have a log 3 button. So just don't forget you need to use, remember we call this the change of base. And by doing it like this, you type log of 60 over log of 3 into your calculator, and it will give you the same thing as log base 3 of 60. All right, this idea mostly went on for the rest of them. So I'll kind of leave it at that. I am going to be a little bit flexible about because that was a tricky one. All right, logarithms, I definitely plugged these back in to check. You did want to round these to 3 decimal places. So again, this is the idea of exponentiating. because if you raise both sides to the same as exponents of the same base, which you can do, all right, you can use the fact that e to the ln e of x, because these bases are the same, these expressions are going to cancel, and then you kind of just go from there. This is more or less what I did for all of them. Just remember, any scenario where you create an equation where ordinarily, right, if I solved, if ordinarily, if this wasn't there, this would have one solution because it's ln of x to the power of 1. Similarly, this would also have one solution, but by pulling them together, you're creating a situation where the new thing you've created has two solutions. And so that's where you want to be super careful. Now, what I did is I eliminated an extraneous solution because I noticed it was negative. And because ln of x, that's going to be a problem. This cannot be a negative number. You cannot take the ln of 0 or a negative, because if you multiply e is a positive number. So if you multiply by e over and over and over again, it's a positive times a positive times a positive times positive, etc. That's going to be a positive. And since e is not 0, it's not going to be 0. So therefore, remember, you cannot take the natural log, or any log for that matter, of a number that is negative or 0. Really, really important. That's basically where the extraneous comes from. All right. And we could continue on, and it turns out one of them is factorable as well. In general, negatives are where you want to be a little bit suspicious. All right, on vicious virus, the trick here was that you didn't get the initial value, p, the principal, and you also didn't get the rate. So remember, there's a couple different kinds of problems you can have. One is I give you the rate. I give you the principal. Mostly, I don't usually give the rate. So usually what I do is I give the principal, because if I gave the rate, there wouldn't be a purpose to needing logs. The logs is to help you solve for that. So sometimes I give you the principal and you just need to get the rate and then figure out. Sometimes I give you two pieces of information so that you need to solve for both the principal and the rate. And that's exactly what I did here. So I said that after 4 hours, there was 100 cells. And then after 4 more hours, in other words, 8 hours, there was 1,450 cells. So what I do is I get P alone, and then I do a substitution. Now this happens right here, remember, because this is e, because of the laws of exponents, e to the 8r minus 4r. Because when you divide, the bases are the same, you should be subtracting the exponents. So that's where that comes from. And then just solving through one at a time and getting the r value here. Okay, solving for p, well, the first thing I do is, well, look, this is 4r, so the 4 and the 4 cancel, and then I get e to the ln of 1450. And remember, these bases are the same, so I can bring the 1450 right down. Now it is 6.897, but I actually decided not to make that substitution because notice the approximate. I felt that I would get a more accurate answer. I kept the r as is, and then I simply plugged in 24 to get that rate of the amount after 24 hours. All right, not so basic. Basically has to do with acidity. And so one thing you might know if you take chemistry is that acidity is related to the concentration of hydrogen ions, H+ ions, that are present, okay? And you'll learn more about that. But essentially, the larger the concentration, the more acidic. So we can see, for example, A versus B, okay? You can see that in B, that number is actually smaller than A because of the 10 to the negative 5. And as a result, you can see the pH value is higher, and a higher pH value means that it is less acidic. It is also known as more basic. Okay, here you can see that you have an H concentration of 3.16. So this concentration, 3.16 times 10 to the negative 8, that's a lot smaller than this, and you can see it's got a higher pH value. Less hydrogen ion, less acidic. Okay, we can see that 2.1 actually has a much higher one, and what I like about this is if you want to compare these, because these are the same, the 10 to the 3 and the 10 to the 3, or the 10 to the negative 3 and the 10 to the negative 3 doesn't really matter. You look at the numerals, 3.89 and 7.94, and because 7.94 is higher, and they have the same, bases, rather the same exponents for the scientific notation, -3, you can be guaranteed that this is going to be a bigger number right here. and a higher concentration of hydrogen ions, you're seeing a smaller pH level, 2.1 versus 2.41. All right, and lastly, with a pH of 12.8, you're going to see a super small level of hydrogen ions. This is going to be 0.1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, versus this one's going to be 0.00794. So you can see this number is a lot smaller, and this pH is a lot bigger, and indicating much more of a base. Last one is crime scene investigator, and I get this one was a tough one, so I kind of spun this one off of an existing one. And the issue when you spin things off is that sometimes the little tweaks that you make actually do make a big difference in the long term. And so since this is a tough one and isn't really perfectly designed, I'm going to consider that when I grade the problem. But if you do notice the original temperature of 83.5 and you plug that in, what comes out of the model is the number 10, which indicates that the person passed away about 10 hours before you took the temperature. And since you took the temperature at 3 a.m., you go back 10 hours, and that would take you to 5 p.m. Okay? So folks, hopefully this video helps you make a little bit more sense of the problems. I do encourage you, if you still have lingering questions, to reach out to me via email and to keep your eyes open for any opportunities for office hours. I'm looking forward to a great midterm and a great class next week. Keep it up, folks. Take a positive attitude. And remember, you can do it. All right, until next time, folks, have a good day.